Hello, I'm Roman, a hardware engineer at Droid Technologies. I specialize in designing both digital and analog devices. My responsibilities include schematic and PCB design, signal verification, prototype testing, preparing the hardware for certification and mass production. In this video, I'll walk you through the complete process of designing a custom PCB, from the initial concept to mass production. We'll cover essential topics such as defining technical requirements, conducting design reviews, manufacturing steps, testing procedures, and more. Before starting any design, it's crucial to have a clear vision of the final product and its functions. Even a small detail can significantly impact component selection and alter your schematic and PCB layout. As a first step, our team defines the technical requirements. Then we select the main components, align key concept with the customer, and create a block diagram showing all connections and interfaces, ensuring the selected components have sufficient performance and available pins. At the same time, we coordinate with other team members, such as software developers and mechanical engineers, to review the chosen parts. Once everything is agreed upon, we move on the schematic design. Our engineers create the schematic based on the selected components and technical requirements, while maintaining ongoing communication with the rest of the team. Once the schematic is completed, the engineers send it to a reviewer, a hardware developer who performs a schematic review. The reviewer prepares a report using our standard checklist template and returns it to the original engineer for corrections. This step is crucial as it significantly reduces the number of potential issues later in the process. PCB design brings electronic circuits to life. Our engineers create the PCB layout by placing components and routing connections to define the electrical pathways on the board using professional layout software. A PCB layout review, just like the schematic review, is essential. It helps prevent many potential issues at the later stages. The engineer sends the PCB file to a reviewer who uses our standard checklist template to prepare a report and returns it to the original engineer for corrections. Once the PCB design is complete, our team generates a bill of materials, the list of components, materials, part numbers and quantities required for prototype manufacturing. After that, we order the components and PCBs and assemble from 4 to 6 prototype units in our lab, either manually or using an SMT machine. Our engineers verify signal integrity, antenna matching if the device includes an RF section, and perform firmware tests. They also test power management, power distribution, and check all signal lines. If any issues are found, they are resolved by adding components and wires manually, with the goal of identifying and addressing all problems at this alpha stage. Our engineers prepare an errata document, the list of all identified issues along the detailed descriptions. This serves as the basis for updating the schematic and PCB in the next revision. Once the first revision has been fully tested and issues resolved, we begin working on the second revision, the beta version. It follows a process similar to the first, with improvements based on prior findings. For a more detailed breakdown, please refer to the workflow on our website. Once the new PCB revision is completed and all functionality and TMI/MC tests are passed, we can proceed with a pilot batch, typically 50 to 100 units for field testing. If the pilot proves successful, we move on to the small-scale production, followed by full-scale mass production. The PCB design is a specific and complex process, especially when the goal is to bring the device to mass production. At Droid Technologies, we're here to assist you with your embedded design projects covering electronics, firmware, software, and mechanical designs to ensure successful implementation and optimal results.